This is an introduction to computer vision. We're going to go through a couple exercises just to show OpenCV how to show images with matplotlib and Pillow, the Python image library, and just go through some of the basics with image processing and be able to read images and export them and modify them in simple ways. We're also going to go through the images and how they're stored, and to help understand how to be able to manipulate those for computer vision and machine learning tasks. So let's just jump right into the exercises here. We're going to first of all need a couple packages, maybe that don't come with Anaconda or your other package. If you see that OpenCV is not installed, you'll just need to do pip install OpenCV-Python. Okay, and then you should see a message that's either satisfied, and if you have an older version, you may need to upgrade. And if you don't have user privileges, just do -- user if you don't have administrative privileges there. Okay, but you can upgrade if needed. And if you get an error on the upgrade, then you can add the -- user. Okay, so that one's already satisfied. It only needs to run once. And let's go ahead and just insert another cell below. We're going to import an image and then start to work with it. Okay, so to do that, we're going to download it with the URL request. And we'll download this image. If we come to the course website and then come down here to computer vision, we're going to import this image right here. Okay, and we'll get it from this URL, or if you want to come here and copy image link, you can do that as well. Okay, so we're going to get it from this URL. Sometimes there's an error if you have the S there, so just I'd recommend taking that out. All right, and then URL lib request URL retrieve, and then we'll retrieve the URL and then give it a name. Okay, so there is our image that we've retrieved. You can see it's downloaded right here to my desktop, and I see it appears right here. Okay, so let's go and insert another cell. Now what we want to do is import that with OpenCV. So I'm going to import CV2 as CV. You can just have it as CV2 if you'd like. CV or CV2 are common. So I've just renamed that as CV. And that's going to be IMRead. And then we're going to import students walking. Okay, so that is now imported. Let's just take a look at this IM object now. All right, so if we just look at it, it's going to be an array. It's a three-dimensional array. And what we have here, let me just go ahead and map this out. All right, so it's a matrix of values. And here are the rows. And then the columns that represent each one a pixel. All right, and at that location, we have a BGR, blue, green, red, if you're importing it with OpenCV, or if you import it with matplotlib, that's going to be an RGB. Okay, so RGB is how matplotlib and the Python image library import. BGR is how OpenCV imports it. So at that location, right here, the very first one, as you can see here, it's 211, 209, and then 201. All right, so if you want to think about it like this, it's like a three-dimensional matrix with three values that go in depth. Okay, so those three values are right here. As you can see from the pixel information, the BGR, the blue, green, and red intensity for each pixel. All right, but let's do some things with this. Let's first of all just get the shape of this. Let's get our height. Actually, I'll just print im.shape. And you can see it's 400 for the height, 600 for the width, and then you can see the 3 pixels there. So we can put those out to values, height, width, and color. All right, and so if we print H, then it's going to be 400. Okay, if we want to print the height and the width, then we can see it's a 400 height and 600 width. Now normally these are, when you talk about images, these are switched. You typically say it's a 600 by 400, the width might come first. Okay, let's come on down. We can resize these as well. So I'm going to do image 1. I'll just create a new image and I'll do resize, and then I'll resize the image. Now we'll do a 300 by 200. Okay, and if we look at image 1 shape, we can see it's a 200 height, 300 width, and then 3 for the pixels. Now you can see here, this is the common way of referring to images, the width and then the height, but it returns the shape as height and then width. Okay, so don't get confused with those image dimensions. We can also resize. A couple different ways to do this. We can resize image, and then dimensions are none, and then we can give a scalar. Like let's say we just wanted to resize it to 50% of the dimensions. So we'll put a 0.5 there for each, and if we do image2.shape, then we can see the same image dimensions. Now sometimes you want to have a little bit more control over this as well, and so you can have a scaling factor. So let's say you just want a new width, for example. So let's say width equals 300, and then we want to get the height, width, and color. We'll get the shape dimensions, and then let's get a scaling factor. All right, and this would be width divided by W. So the new width, okay, is going to be half of the old width of 600, and then we can calculate the new height. Okay, we want to make sure that's an integer, so we're going to do that old height times the scaling factor, in this case 0.5. And then we can get the dimensions, and this is going to be width, comma, height. And then we can resize that, same as we've done before, but it gave us just a little bit more control over the exact dimensions we wanted to use. All right, and then if we do image 3 shape, then you can see it's the same as it was before. All right, let's go ahead and go down to just displaying the images. Now I find that matplotlib is a little easier to display images, especially in a Jupyter notebook. If you use OpenCV, sometimes it can crash the kernel. It holds it up at particular points in your notebook if you run and show that. In fact, Google Colab also says, hey, the image show is not allowed, the OpenCV one at least, is not allowed in Jupyter Notebook because they say there's an issue with it. Sorry, not Jupyter Notebook, Colab. Okay, so Colab, Google doesn't allow OpenCV image show. So you can use instead, you can use PLT image show. Okay, and let's see what our error is here. Okay, so no such file or directory. Oh, instead of PNG, it's a JPEG. Okay, so it shows the image. It also gives a nice marking here to show the the pixels. Okay, so the pixel location, it adds it like a typical graph would. All right, now we can also do that. We can take our original image. I'm just going to show what would happen with image show if you just imported the original one from OpenCV. So you can see that the blue and the red are switched. Now you can still show this with matplotlib for ones that you've opened with OpenCV just by changing the indices here. So we're going to go with all the rows and all the columns. but we're going to switch just the very last one. We're going to switch that from 0, 1, 2, like it is normally, to 2, 1, 0. So if we do that, we get people that don't look like they're blue, and we've just switched the pixels here, okay, to get it back to the original form. So when you don't have that, you can see the effect. The 2 pixels are swapped, and if you just swap those to show them, then you can get it back to the original image. Okay, so let's go on to how to do this with OpenCV. Even though this could crash your kernel, let's just go ahead and show how this is done with OpenCV. We're going to do cv.imageShow, and I'll give it the name and the image, and then we'll have to name the window. And then we can do window auto size. Then you need to have this wait key in here. And it just waits for a key press. And then if you do destroy all windows, then it allows it to continue on. So let's just see if this is going to work. Okay, I think it crashed probably held up my kernel. As you can see, this is, sometimes this happens. Let's see if I have this. Oh, there it is. Okay, so it popped up, and then I have to go in and close it. So you can see it looks a little bit better than this other one. Okay, OpenCV, does a good job of displaying the image. And one of the things you'll notice is that OpenCV is not just a Python package. It's for other languages as well. So this is a Python interface to the OpenCV package, but most of the other function calls are also available in other languages as well. Okay, so after I close that window, you can see the asterisk went away, and then I'm able to continue on. So let's just show these side by side. I'm just going to copy in this code here, an example of how to read it in both ways. And so we have the BGR is OpenCV and the RGB is matplotlib. Okay, so I've just put those side by side. All right, now let's go ahead and just get into how we write an image. So if we want to do CV after we've resized it or something like that, we've modified the image. Let's say I have students.png. I want to save it instead of a JPEG as a PNG. Then I can do that, and then I've written the image out as a PNG file. You can see the dimensions there are 600 by 400, and you can see it's just converted it to that other form. Okay, so I've converted it from a JPEG to a PNG just by using the image write. Let's go ahead and insert another cell, and let's talk about some video as well. So I'm going to import CV2 as CV. We've already done that, but I'll just go do it again. I'll put time in there as well. And then I want to get the camera. And I'll do video capture. And I'll just get my very first webcam. If I have more than one webcam, I can change which one I grab it from right there. And let's get the width. This one is going to be camera get, and then in here I'm going to do CV cap prop frame width. Okay, and then let's get the height as well. All right, and this is just going to be, instead of width, it'll be height. Okay, so I can run this. It's going to just takes a little bit for this video capture to start. But you can see the video capture dimensions that I have from my camera. Now, if you want to write out the video, we're going to do out equals, and we're going to create a video writer. And just give it a name. This one will be video.avi. And then you need some type of encoder here. Video writer. And I'll use the 4cc. And the asterisk, I'll use the xvid. Okay, and then I'll say 25. All right, and then WH. So that's like I think that's the frames per second, and then I have the width and the height. All right, so there's my video to be able to write the video. As I read it in, I want to write it out. All right, and then let's just create a window name. This is just going to be my view, and so we can see it as we're running. Okay, this is a named window, and we'll give it the window name. And this will be CV, and then I'll window auto size. All right, let's go ahead and start. I'll just get the time, and then while time.time. So I'm just going to pause this or stop it after 5 seconds. Less than or equal to 5. All right, then I'm going to capture the video and store it. So let's go ahead and get the frame. All right, it's going to return any error messages or other things from that. Okay, I just really want the frame. That's the one that I want to read in. And then I can do CV image show. And let's have our window name with our frame that we're going to show. All right, and then we want to use our video writer. This is our out, and we will write the image, and that's going to be a frame.jpg. Okay, so we're writing is to this video. Okay, and then we're also going to do wait key. And I'll put in 1 there, and okay, so if I hit the Q key, then I'm going to stop. All right, so it's going to wait at least 1 second. If I hit the Q key, then it will break. And then as a final thing, let me just write frame.jpg, and I'll just write the last frame. All right, let's take our camera now and we'll release it so that we can use it later, and then we'll also stop the recording, create the AVI file, and then we'll close the window. Destroy all windows. Okay, so let's go ahead and run this, and hopefully this will come up with the video here. It's going to take a little bit just to get, okay, let's see how that, oh, CV2. I need to close the program. Sometimes if you don't get it quite right, then it, okay, so I got to find the error here. The video writer. Oh, I need to do out, image write. Oh, I need to do just the frame, not to the file name there. Okay, so I'm going to do that later. I'm just going to do CV image write, but the video writer itself doesn't write to the frame.jpg. It's writing to this AVI file that I specified up here. All right, let me see if I can run this again and see if this will run. It looks like it's a dead kernel. Okay, so let's go ahead and just restart the kernel. I'm going to try to run it one more time here. And I might have another error. We'll see. Okay, so CV2 video writer has no, oh, I messed that one up. It's just write. Okay, not image write. We just have write here. All right, let me try that one more time. I'm debugging real time here. Okay, so you can see the video.avi. It did create that, and looks like it did. Okay, so let's go ahead and run this again. I want to see if I can bring this window up and be able to show it. So it's there it is. Okay, so it's just recording 5 seconds of it, and then it ended, and there you can see an AVI file. Okay, no sound with it, but there is the AVI file. And then it stored this last one right here with this frame.jpg. All right, so that's how you record video. You can collect it with OpenCV. And anyway, so it's pretty easy to do. It's going to create an AVI file. You can also encode it in other ways like MP4 or other methods with OpenCV. But what I wanted to show as well is just some additional information here. So after we've gone through all of these, okay, there's a really nice 3-hour OpenCV tutorial where he goes through starting kind of from the basics, similar to what we've done here, but a little bit more detail and with a couple case studies as well. So that one is a 3-hour video. Encourage you to take a look at that. The other one is a demo of what you can do with OpenCV. I've just created this race timer. So I enjoy running and I enjoy coaching, and I've just created this race timer to help out with some of the track meets. So if you go and download that, you can see this race timer, and I'll just start this. So what it does is with OpenCV, it takes the web camera. When you hit the space bar, it starts the race, and you can see the timer there. And you can hook this up to a screen, and then when somebody crosses the finish line, you just hit the space bar again. It takes a photo of them, and so I'll put my hand up here just to show that the photo is different, or over here. Okay, so you can see the finishers that came through, and then as it continues, you keep hitting the space bar for maybe longer races like cross country or others where there might be 100 in that race. You can see the top 3 finishers, but then it also records the times as you go. So all of this is done with OpenCV. I'll go ahead and hit escape or Q. Okay. And then you can come into the folder. You can see it created this folder, and it created a photo finish for each finisher. Okay, with their time. And for the top 3, we gave them the medals there, gold, silver, and bronze. All right, and then the other thing it did is it created this CSV file where it recorded all of their times as well that you could import into some other type of results package. All right, so that's just a quick example of something that you could do with OpenCV, many other things that you can do as well. So there's some very nice, in addition to computer vision, there's some machine learning and other things that you can do directly within OpenCV. We're going to use all of this information and then go on to a couple related computer vision activities. We're going to use cascade classifiers, and in particular, this local binary pattern. So we're going to do a case study with LBP, and then we also have deep learning and using convolutional neural networks to be able to classify images and what you see in those images. And so there are many different applications here. So for example, we have facial recognition, we have hand tracking as well, and then you're going to be able to see others like texture classification. This is with the local binary pattern, and then the convolutional networks. we're going to have soil classification is one of them with a convolutional neural network. And then you'll also see bit classification. Now this one has two of them. This one identifies images of drilling bits and what type of bit they are. And then you also have concrete cracks down here as an exercise. So we'll get into more on what you can do once you've imported the images and start to work with them, rescale them, how we can train these computer vision methods for classification and be able to recognize what's in the image or what is the significance of something that's in the image, like a concrete crack. All right, well, I hope you've enjoyed this tutorial and this introduction to computer vision. We're going to be spending a little bit more time going through some of these tutorials together.